Hi, everyone. I'm Shaun Walker, and I'm excited to share some exciting new technology with you today. The title of my session is Playing with Fire, Blazor on Oqtane. And I don't know if Playing with Fire is the most appropriate title, but I'm sure it got some people's attention. This is definitely new Microsoft technology that I'm going to be sharing today, and I definitely don't think anyone's going to get burned um, by the content that I'm going to be presenting. So as part of the agenda, I'm going to be talking a little bit about Blazor. So just giving you a summary of this exciting new technology that Microsoft released a few years ago that is just starting to get some more mainstream adoption lately. We're going to talk about application frameworks and why they're relevant for software developers. We're going to talk about Oqtane, a new framework that's built on Blazor, and get into the application development side of things related to Oqtane. So I'm Shaun Walker. I guess my claim to fame is that I was the original creator of .NET Nuke. I was one of the founders of DNN Corp, which was a company that was formed to commercialize .NET Nuke. It was a Microsoft MVP for many years, an ASP insider. I'm also the creator of Oqtane that we're going to be talking about today. And I'm also the chair of the .NET Foundation Project Committee. And that committee is focused on reviewing the needs of the various projects that are part of the .NET Foundation. And in fact, Oqtane is a member of the .NET Foundation already. I've been lucky enough to participate in a variety of different books over the course of my career, which are sort of displayed on this slide. And let's get started. So first of all, let's talk about Blazor. So what is Blazor? I'm sure a lot of Microsoft developers have heard about Blazor by this point in time. Probably a lot of you have not had the opportunity to experiment with it yet, or if you have, you haven't built anything substantial with it. The concept behind Blazor is that it's a single page application framework that's designed for building interactive web apps with .NET Core and specifically, I guess, C#. The main, I think, goal behind Blazor is the fact that rather than focusing on JavaScript based frameworks, you can focus on building applications with C#. So if we talk or focus for a bit on single page applications, I think most of us are familiar with these nowadays because most of the enterprise applications that we're building today are using a single page application architecture. So the concept behind a single page application is you have a client and a server component that's part of this architecture. The client basically sends the initial request to the server. The server responds with some HTML payload, which is, constructs the initial page. And then from that point on, the client actually sends more granular requests to the server asking for additional data, which is sent back in the form of JSON. But a lot of the interactions that are happening between the user and the application itself are happening in the client. Traditionally, that has been happening in JavaScript frameworks such as React, Angular, and Vue. And with Blazor, it allows you to build applications in native C# that run in the browser and allow you to have a single page application architecture as well. Some of the interesting things about Blazor is that there is a consistent development model that it provides to you, built around the concept of Razor components. But then you can use those Razor components to host them in a variety of different ways. Currently, a couple of the ways that are already supported by Microsoft are Blazor Server, so running Razor components on the server. And the other way is running components natively on the client via WebAssembly. There's other ways that Microsoft is looking to allow you to run Razor components as well in the future. And so this makes this technology very, very adaptable to a lot of different scenarios. And the cool thing about it is that you can learn how to, learn the Razor component model, and then you can target a variety of different hosting models using that same technology. So let's talk a little bit about Razor components. So, I mean, if you have a page in your browser that is made up of a bunch of different application areas, those areas, each of them could be a component. And a component is made up of, well, basically it's a Razor file, and it's made up of both markup and C# code. So you'll have the markup that's part of the Razor page, and then you'll have the C# code as well that's reacting to various events. Blazor components support property binding, which allows you to, bind your data to the markup to refresh the user interface. And it also has event binding so that you can react to different events that the user might have, like such as clicking on a button or things like that. And you can catch those events within your C# code and react to them appropriately. So this is a very powerful model. This diagram is probably reminiscent of what you've seen for Angular as well. So Angular, React, they all follow a similar type of component model with very similar concepts as well, where you have markup, you have the ability to write application logic, you have property binding, and you have event binding. So Blazor has emulated that model very successfully, and it gives you sort of the full set of capabilities that you might need in building out a component model. Focusing on the hosting models now, you've got Blazor Server. Blazor Server is basically still using Blazor components, like I mentioned earlier, and those Blazor components are actually running on the server itself, and they are communicating with the browser via SignalR. So basically, what happens in a Blazor Server application is whenever there needs to be some refresh that needs to happen to the browser in the DOM, there's a SignalR request that goes back to the server. And so there's continuously activity that's flowing across that SignalR connection so that you can interact between the browser and the server, and you have sort of native application-like speeds by doing that. So you can simulate basically a single-page application model with that sort of high responsiveness and reactive UI that you expect. However, all of the application logic is in fact running on the server. And rather than having a full page refresh, so the entire page being sent back to the browser and refreshing, you only have the granular updates that are being sent back. So it's a fairly efficient model as well. Of course, you also have Blazor WebAssembly, which is an alternate way of hosting your application. In this model, the Blazor components are actually transferred from the server to the client, and they will run natively in the client by leveraging WebAssembly, which is a technology which is available in all modern browsers today. And many, many different application platforms and different languages are targeting WebAssembly already. And Blazor uses this technology as well, so that you can run native .NET utilizing a mono-based runtime that works with WebAssembly natively. And when you're running in this model, you basically, your DOM is being refreshed on the client side, because you have all of that application logic that's running in the browser natively. And so it does the refresh of the user interface natively within the browser. This is very similar to the way that React or Angular or Vue works today, where your user interface is actually being managed completely within the browser itself. And the only calls that go back to the server are when you need additional data, where you would call APIs on the server and ask for additional data that could then be used to refresh your browser. So this is a very attractive model for those types of applications where you want that full native type of experience in the browser. And it's an alternative, of course, to using a JavaScript frameworks that I already mentioned previously. Of course, the benefit is that you can write your Blazor components natively in C#. So you'd be able to leverage the same like technology model on both the server and the client, as opposed to in a JavaScript framework world where you might have backend developers that are writing the backend in C#, but you have to have developers who are fluent in JavaScript to deal with the client side, or they have to be context switching between different types of technology, which is obviously not very efficient. So, I mean, the Blazor technology model allows you to use the same skills and the same technology both on the back end and the front end. Looking at Blazor and the history behind it, a lot of people are just becoming exposed to this new technology now. However, it's obviously been under development for quite some time. The original proof of concept was introduced in June of 2017, which is obviously quite some time ago. the initial announcement where Microsoft pulled it into the ASP.NET team and basically made it an experimental project was in February of 2018. An official preview of Blazor where Microsoft basically said it was an official product that they were going to ship in the future was in April of 2019. And this is when it was merged with .NET Core 3.0 and became part of that, that release train. .NET Core was released in September of 2019, and it included sort of a general availability version of Blazor Server at that point in time. So Blazor WebAssembly, although it was possible to write applications using Blazor WebAssembly, at that point in time, the only official hosting model for Blazor was Blazor Server. As we move forward to .NET Core 3.1, which was in December of 2019, this was the .NET Core LTS or long-term support release. So that, of course, included Blazor Server as part of that release. And I'm calling this out because a lot of enterprise customers prefer to use long-term support releases as part of their infrastructure, as opposed to general availability, which tend to have a shorter time frame for support. Microsoft followed up .NET Core 3.1 with, I guess, .NET Core 3.2. That was more of an internal version. Realistically, it was still .NET Core 3.1, but .NET Core 3.2, which came in May of 2020, included support for Blazor WebAssembly, at least in a general availability form. So this is, a go live type of license where you could run Blazor WebAssembly applications and build them and run them in the wild. But of course, this is still a general availability release, not a long-term support release. .NET 5 is the next major release, which is coming, and that is going to be available in the next couple of months. So November 2020 is the target for .NET 5, and that's a general availability release. There's a lot of things that are coming along with .NET 5, but in particular, of course, Blazor Server and Blazor WebAssembly, as well as some new capabilities for Blazor are coming as part of that release. And then looking further out in the future, you've got .NET 6, which is already scheduled to be in November of 2021. And that'll be the long-term service or long-term support release that a lot of customers are looking forward to. Focusing back on Blazor and sort of the evolution and also looking towards the future of where this technology is going. But if we start at the top, we'll notice that Blazor is expected to run the gamut all the way from web through to desktop and mobile scenarios. Of course, it started with web, and it originally started with Blazor Server. That was the first version, and that's obviously the Blazor technology running natively on the server and working with the browser via SignalR. Next came Blazor WebAssembly, and that's the capability of running native C# code in the browser, running on top of WebAssembly. And this is, of course, available today. A progressive web application capability for Blazor is also already available. Typically, this is built on the Blazor WebAssembly model, and it allows you to use service workers in the browser and create sort of hybrid type of web applications that can simulate a mobile capability as well. So progressive web applications are very popular or gaining popularity in a variety of different scenarios because you can use the same technology and the same application logic to run both of your web as well as your mobile device interfaces. But as we look forward to the future, we're going to have a number of additional capabilities that are targeted for Blazor. So Blazor Hybrid and Blazor Native, and these are capabilities of actually building mobile applications using the Blazor technology. And if we look at things that are already available, so the mobile Blazor bindings was announced at the same time as the Blazor WebAssembly release in May of 2020. And this is still an experimental project from Microsoft, but it enables developers to build native and hybrid mobile applications using .NET. Of course, this is tied in with Xamarin, And so, I mean, but this, like I said, is already available. So you can go and find and download the latest code for mobile Blazor bindings and start building applications with that technology stack. It's quite interesting in that, I mean, it allows you to use your, your C# and .NET skills to build native applications or native mobile applications. And this would be an alternative to building those applications in XAML, which is, the typical way of building applications in Xamarin. This is an alternative to that where you can use the Blazor Razor component model. And it's obviously a very powerful technique if you really like the Blazor component model. So transitioning a bit to application frameworks. So what is an application framework? So it's a software framework that is designed to accelerate the development of web applications, web services, and web APIs. Web frameworks provide a standard way to build and deploy web applications. Web frameworks aim to automate the overhead associated with common activities performed in web development. So I'm going to talk a little bit about application frameworks because, I mean, they're relevant to this particular talk in the sense that both Blazor and Oqtane, which I'm going to be sharing with you shortly, are both application frameworks, but there are some differences between them. So I need to explain what those are. If we look at application frameworks, all the way from building applications without a framework, all the way on the left-hand side of this diagram, all the way to the right where you are building applications with a fairly substantial framework, there are some things to keep in mind. So if you want to build an application and have ultimate control over every aspect of that application, you might not want to use a framework. You might want to build that from scratch. However, in order to get that level of control while in building that application, you are going to obviously do everything from scratch, and you're going to lose out on some of the productivity benefits that happen or that come as a part of building on top of a framework. Now, there's different types of frameworks. There's sort of minimalist frameworks, which provide only sort of basic types of services and still require that you build, a bulk of functionality within your application itself. Or there's frameworks that provide a whole lot of functionality and obviously reduces the amount of custom code that you have to build for your application. It's really depends on your specific requirements and a lot of different aspects you have to keep in mind in terms of the cost, the schedule, various things that you have to consider when you decide on what type of a framework you want to build on. The Blazor technology that as it exists today is more of I guess a minimalist framework. I would say it provides a lot of the basic functionality for building a component-based application, but there's a lot of additional services that it doesn't provide today and probably never will. The framework that I'm going to be talking about in a few moments, Oqtane, is more of a full stack framework where it provides a lot more of the services that are not provided today in Blazor. And so that's why you might want to consider using it as well. The other thing to keep in mind when you consider different types of frameworks are that sometimes there's like as a starting point to build an application, you could use a template. Typically, Microsoft provides templates for various applications. So if you fire up Visual Studio and you want to go, create a new project, there's typically a template that you can utilize to create, the basic application using that particular technology. Sometimes there's more advanced things that you can use, sometimes called boilerplates, which provide a bit more functionality than basic templates. But the thing to keep in mind there is that when you're using that model, the application and the underlying sort of framework are sort of mixed together. They blend together, and there's really not a whole lot of distinction between them. And that poses some challenges moving forward because it makes it more challenging to upgrade your overall application if you want to take advantage of new features that might be available in newer templates or new features that are available in like newer boilerplate applications. So obviously these are still a great way of accelerating your development efforts, but there's some downsides. You can contrast this to modular frameworks, which are on the right-hand side, where the architecture much more cleanly delineates the underlying framework from the applications that you're going to build from scratch. So the framework itself is physically and logically separated from your application, but there's obviously integrations that you can do to pull these together so that you create one sort of cohesive application from an end user perspective. The benefit of this model, of course, is that as the framework evolves, you can upgrade it much more seamlessly, as long as the maintainers of that framework maintain compatibility across various versions, of course. But that is usually one of the attributes that framework developers try to keep in mind as they create new versions. But so you would be able to upgrade to newer versions of the framework and immediately be able to take advantage of the new features. And it would allow, it provides, a much more maintainable model for as you move forward into the future. Also considering sort of the modular approach and a concept that's become a lot more popular in recent times is the concept of micro front ends. So for a long time, we've been talking about microservices and breaking up your back end logic into individual services, which are a lot easier to maintain individually. You can deploy them individually. So there's a lot of benefits of micro services. However, the front end traditionally has still been a monolithic front end. So you have a monolithic application which talks to back-end microservices. The problem is that, of course, that monolithic front end, if you have many different teams that are working on it, it still has to, you still have the possibility of stepping on each other's toes. You still have the challenges of that you need to deploy the entire front end in one sort of monolithic piece of application code. And that poses some challenges. Whereas on the right-hand side, if you break up your application into individual modules, and each module takes on responsibility for the user interface for a specific area of your application, that means that you can maintain them independently from one another, you can deploy them independently from one another, and then of course they are all pulled together by the overall framework to provide the cohesive view to the end user. So of course, that's the benefit of a modular approach. And micro front end approach is that you can more granularly manage the needs of your application as you move forward. So now we're going to transition over and talk a little bit about Oqtane, which is a new framework that is basically a modular application framework that's been built for Blazor in particular. So the mission behind Oqtane is to provide a modular application framework which accelerates the development of modern digital experiences. Some of the themes that were in mind in the creation of Oqtane are just speed, extensibility, and productivity. Focusing on the speed concept in particular, most people would think of speed as being the runtime speed, but speed can be applied to a lot of different characteristics. Could be applied to the speed at which you can get up and running with the framework, the speed at which you develop new functionality, of course, the speed at which you can deploy as well that functionality into various environments, and of course the runtime speed as well. So aspects of speed that are part of Oqtane, and of course, I mean, this bears resemblance back to the fact that the Oqtane brand name, I mean, the name Oqtane itself is a measure of performance for fuel, and so I mean that everything related to Oqtane is related to the concept of speed. So digging into a little bit further into Oqtane, so it's a modular application framework that was built natively on Blazor. The idea behind it is it allows you to rapidly create modern web applications, hopefully using less code than you would have to if you were building applications from scratch. It provides a robust set of building blocks which allow you to leverage those building blocks and not have to build the functionality on your own. It is open source. It's available under an MIT license. As I mentioned earlier, the Oqtane project is a member of the .NET Foundation. So the .NET Foundation actually owns the copyright for Oqtane, and it is responsible for ensuring that the code is available under the MIT license indefinitely. And Oqtane provides a lot of capabilities that are not currently available in Blazor. So what are some of those capabilities? Well, it's multi-tenant. So um, building multi-tenant applications is quite complicated. However, it is a capability that a lot of applications need. So the ability to run multiple types of applications from the same code base is something that Oqtane provides out of the box. It provides a portal UI framework, which really drives that micro front end strategy, and it allows you to deploy individual modules and then pull the user interfaces for those modules together into a cohesive story for the end user. It has more advanced security capabilities and granular permissions that you can apply both to the user interface and to your backend services. It has a whole administrative user interface as well, with a lot of functionality which helps you manage your application and provides capabilities that you don't have to build yourself from scratch. It uses dynamic routing so that you can build applications with as many different pages, and you can create those pages dynamically, and then place the various elements on those pages without having to do that in code. Uses a modular architecture, which I'll cover in more detail in a moment. It has customizable themes where you can change the entire look and feel of the application and really have full sort of design flexibility around it. And on the back end, it has a headless API and repository built in using very modern technology. The Oqtane community is available on GitHub. So there's a full open source project and a variety of related projects that are available in the Oqtane organization on GitHub. So this is how you would get access to the latest code, the various releases that are available. The roadmap behind Oqtane. So initially there was a proof of concept that was started in November of 2018. It was originally started actually on Blazor Preview 5. So this is before Blazor was even available. The official announcement of Oqtane as an official project was on May 5th, 2019. And this is when the open source project was created, and obviously the community was invited in to help participate on the development of the code. Oqtane 1.0, so the official 1.0 release, was released on May 20th, 2020, and this coincided with the release of .NET Core 3.2, which was, of course, was the release where Microsoft made Blazor WebAssembly fully available as a supported technology. Since that May 20th, 2020 release, there's been a number of stabilization releases. So the latest stabilization release was Oqtane 1.04, and that was last week. And the next major version that is being worked towards is Oqtane 2.0, and that will be available in November, and it will coincide with the release of .NET 5. So Oqtane will move to .NET 5 and be available immediately upon the release of .NET 5. And the reason for that is there's a lot of a great functionality that Microsoft has baked into .NET 5 around Blazor, and Oqtane wants to be able to allow developers to take advantage of that capability. So in terms of application development, the system architecture around Oqtane is pretty robust and pretty modern. So I guess starting on the server side, if we look at the bottom of this diagram, you'll see that it's built on .NET Core and EF Core as the underlying technologies. There's an Oqtane repository, which provides access to all of the different domain objects that Oqtane supports. There's on top of the repository, there is a REST API. So an API that includes full Swagger support. So it has the full documentation for the API. There's also a capability to run scheduled jobs in Oqtane. So you can build jobs that run asynchronously on a particular schedule. And it'll basically run functionality for you in the background. And this is, of course, this is all native .NET Core technology. So it runs within the application server and doesn't require any special configuration in order to run scheduled jobs. Each module that create would have, of course, its own API, and those are all deployed on the server. Oqtane currently supports SQL Server as its backend data store, and it supports multi-tenancy, which, as I described earlier, And it's pretty powerful in the sense that it has both support for shared and isolated tenancies. So um, within your SQL Server database, you can have multiple sites, and a site could represent, many different types of applications that you want to expose to end users. You could store all of those in a single tenant, which would be a tenant is synonymous with a database, or you could actually split it up so that you could have individual and physically isolated and separate databases for each site if you so desired. And of course, you would still have one code base, but that code base could basically support multiple databases if you need that ability to keep things physically separated from one another. So that's a pretty powerful capability from a multi-tenancy perspective. Moving up into the client area, we're of course running on Blazor, and that could be both Blazor Server or Blazor WebAssembly. It supports both with the same code base today. There's basically a single application configuration setting that you can set in the app settings, which basically says whether or not you want to run the application on Blazor Server or Blazor WebAssembly. So on top of Blazor, we've got our Oqtane services, which are API wrappers, and these API wrappers leverage HTTP client to call the Oqtane REST API. The API wrappers make it very simple for developers who are, of course, writing Razor components to be able to target the Oqtane API. On top of that, we have our multi-tenant portal UI framework. So this is the portal UI framework, which, of course, allows you to create a composite UI based on the various modules that you have available. The multi-tenancy aspect allows you to run multiple sites, and each of those sites can have an unlimited number of pages, and each page can have basically an unlimited number of content and modules that you want to display on them. You've got your Razor components, which are where application developers would focus their efforts in creating, custom applications. And there's, of course, these modules, this is the user interface aspect of them. So and this is using the Razor component model. And of course, it allows you to also target not just, standard web browsers, but you can target mobile devices as well using the responsive design methodology. So that's the overall architecture for Oqtane. Oqtane supports dynamic page routing. So basically, and this ties back into the multi-tenant aspect of the framework. So it can support basically routing based on URLs. And so you can have a variety of different URLs, which we call aliases, that you can register in the system. Each alias can be associated with a particular site, which is a logical designation within the system. And then each of those sites can have an unlimited number of pages. And so basically the system takes the domain name, looks it up in the alias area, cross-references that to a site, which then cross-references that to a page. And that's how it can figure out using the dynamic router, which page needs to be displayed to the end user. The portal UI framework allows you to combine a variety of different types of content together in a virtual page. And like I said earlier, these pages are virtual. They're not physical pages like you would normally create in a Blazor application. Pages are a virtual concept. So you can create as many of them as you want because they're basically just configuration. So you create a page, you apply a specific theme to a page, and the theme provides the look and feel and the layout for that page. And then within that, you would a theme can have a variety of different panes, which are sort of the different content regions that are part of the page. And then you would include as many different types of modules or types of content as you want within the different panes. And that is all assembled dynamically at runtime based on configuration, which is stored in the database. So none of this is static. So you don't create pages where you hard code modules within actual Razor pages themselves, right? This is all dynamically generated, which provides a whole lot of flexibility in terms of creating applications. Module routing takes advantage of sort of the same sort of routing capabilities. It's all uses a custom router within Oqtane. And so it builds on top of the routing that we talked about earlier. But this is how, if you have a particular module that's on a page, and that module might have a variety of different Razor components which are part of it, this is how you would expose those Razor components. So in this particular case, there's a module that might be on the home page. That module might have an ID of 1, and then that module might have a variety of different components which make up the different user interfaces of that module. Might have a standard view, which is the index view. It might have the ability to edit content, which is part of the edit view. It might have some other configuration settings, which are part of settings. And so this is all exposed by using the URL and the dynamic routing capability. And then on the back end, it is cross-referencing the information that's provided in the route to the configuration that's in the database, and it's dynamically rendering components. So, I mean, this is one thing. If you're interested in how to dynamically generate or render components in Blazor, basically Oqtane is fully based on this dynamic capability. There is no static really aspects to component rendering in Oqtane. It is all dynamic. So you can see great examples of that in the code base. If you're building modules in Oqtane, you have a sort of a standard architecture that you would follow. So you would use the Razor component model to build your user interface. You could basically, this follows the same exact architectural structure as the Oqtane framework itself. So there's a client and a server component. So two physically separate projects to manage those types of assets. And then there's also a shared project as well, which is shared between them. The client project has the Razor components, and it would have your services, which are your wrappers that you could use to target your APIs that would be on the server. You have a shared project, which is where you would declare your different models. So the different shapes of the data that you need to share between the client and the server. You have your controllers, which are, of course, based on Web API, and this was expose your endpoints of your application to your client so that it can, call it in a secure manner and get data back. Underneath the controllers, of course, you would have your repositories, which are, your code, which would interact with the database itself, and this would be built using EF Core. So these are the different aspects of building a module for Blazor. For packaging, Oqtane uses NuGet as its packaging mechanism. And so just like you would use NuGet to package any type of a component in .NET Core, you would use NuGet to package up your module. A NuGet package in Oqtane can contain one or more assemblies. Each Oqtane assembly can contain one or more modules. So you don't need to basically split things up and have one module per assembly. You can combine multiple modules into a single assembly if you want to. At runtime, Oqtane will be able to look into the assembly and find all of the modules that are part of it. An individual module can contain one or more Razor components as far as a UI capability is concerned. And it might also contain an iModule interface, which is where your metadata related to your module might be declared. Of course, the iModule interface is actually optional. You don't need to declare it. From a deployment perspective, we've got our module, which is displayed here in the middle. A module, like I said earlier, follows the same sort of architectural pattern as the Oqtane framework itself. So you have a client project, a server project, and a shared project. The one thing to keep, and basically a module, at least for the client side of a module, it's a Razor class library. So you're compiling your Razor components into a Razor class library. So it's still compiled into a DLL. Your module would also have a backend, which would be your APIs and your repository. These would also be compiled into a DLL. So depending on, I guess, where you want to deploy, you have to sort of keep in mind where these assets need to be copied. So your assemblies and your debug symbols would need to be copied from the modules bin folder into, if you're working in development, you'd copy it into the bin location for development. Or if you're in a runtime scenario, obviously the way that the folders is organized is differently. So when you publish an application out of Visual Studio and you run it in a more traditional runtime environment, obviously the folders are structured slightly differently. But you need to just pay attention to where these assets need to be copied. So when you're building a module, your assemblies need to be copied to the appropriate location where the assemblies reside. And then your static assets, which would be things like your style sheets, any JavaScript files that you might have, or images, those need to be copied to the www root folder in a particular location that is specific to Oqtane. So Oqtane has a subfolder under www root called modules, which is where the module's static assets are expected to be located, and they're supposed to be in a subfolder which matches the naming convention for the particular module. And similarly, when you're running in a more runtime environment, same exact model is used in both cases. So this just shows you where the assets need to be deployed. And this is important to keep in mind when you're deploying an Oqtane application. So as part of a demonstration of Oqtane, there is an application that was built for the .NET Foundation to keep track of the various projects that are part of the .NET Foundation. This project interfaces with GitHub. And so basically you declare the various projects that are part of, that you want to track in GitHub. It calls out to the GitHub API. And it retrieves data related to various repositories, and then it visualizes those in sort of a dashboard display. This is important from the .NET Foundation perspective because we like to keep track of the various activity in the various projects that are part of the .NET Foundation. And so this was a good application to build in Oqtane. I'm going to switch over to Visual Studio now and show some aspects of Oqtane. So I have a version, the latest code for Oqtane, which I've taken from the GitHub repository. And you'll see here, I've opened the solution up. There's a client project, a server project, a shared project, and we can ignore the other projects for now. In the server project, if I open that up, I can see that there's an app settings.json file. If I open that, I can see that by default, it's designed to use the Blazor Server runtime model. Right now, it hasn't been configured yet, so I don't have a connection string. I'm going to go ahead and run this application. By doing that, it's going to realize that there isn't an actual database which has been set up yet. So it's going to display a installation wizard for me, which will basically provision the application. So this is the installation wizard. I'm going to accept the defaults and just use local DB. Because it's the simplest thing to use for development purposes. I'm going to set up my host account. I'm just going to use a bogus email address for now because it's not important for this demo. When I click install, it's basically provisioning the database for me. So, and it created some basic content for me. Created a couple of pages here with some basic content on them. I can go ahead and I can log in using that account that I created or that I specified during the installation wizard. So host and then enter my password. And when I log in, I can now see that there's an additional page here, which is only visible to users that are logged into the site. And there's some additional capabilities as well. So if I'm on the home page and I click on this pencil icon, I can see that there's a content pane that's declared here. You can have as many different panes as you want, but this particular theme only has a single pane that's displayed here. So there's a block of content here, which is a specific module. There's another block below it, which is another module, and then another block below it, which is a third module. Each of these are independent modules, instances, which are on this page. I can click edit, and it pops up the ability to edit the content. So there's a rich text editor that I can use to enter content. The one thing to keep in mind, which I'm going to call out, is Oqtane has some content management capabilities, like I've just shown you here, where you can edit some basic content, but it is not a CMS. It is not a content management system. So if you're expecting to get a lot of the functionality that is available in other content management systems, that is not part of Oqtane. Oqtane is a modular application framework, which is really designed to allow you to build applications on Blazor, build modern web applications. So we've looked at some of the capabilities here in edit mode. If I hover over this, this icon here, there's the ability to manage the settings for the module, the permissions for the module. So these are all capabilities that are part of that composite user interface model. This particular module allows you to also import and export content. So a lot of the capabilities, and for those of you who are, I guess, familiar with .NET Nuke, a lot of the user interface functionality is very similar to .NET Nuke, because .NET Nuke was, in fact, of course, one of the inspirations behind Oqtane. I was the original creator of .NET Nuke, so I'm very familiar with how it was built, the architecture behind it. And I wanted basically to have a modern version using modern technology, .NET Core, and modern capabilities for user interface development. And I wanted it to emulate the capabilities that were available in .NET Nuke. So for those of you who are familiar with .NET Nuke, there's a lot of similarities. If I hover over the other icon that's up here, I'll see that there's some additional capabilities that I can get access to as part of the control panel. So there's an administrative dashboard with a lot of capabilities there. I can add additional pages to this particular site. I can edit the characteristics of a page. I can delete pages. I can publish and unpublish a page, which basically sets the security for it. I can add additional types of modules to a page as well. So if I close this and let's say I go to this private page, there's only a single module here. Let's say I want to add a module to this page, so I can select another HTML module. I can say I want to add that to the page. It's added. Close this. I go into edit mode. Say I want to edit the text. I can add some text, save it, and it's added. So it's very, very simple to add modules to a page. Of a My Page as well. One of the things that if you want, well, first of all, let's look at the administrative functionality. So if I go into the admin dashboard, you'll see a lot of the additional capabilities which basically come with Oqtane out of the box. So site settings, so the ability to manage various aspects of the site, things like the name, some of the titles, the aliases that map to a particular site, whether or not you want to have a logo, the theme, that's the default theme that's related to a site, setting up your SMTP settings, whether or not you want to support progressive web application. All this is available in the site settings. You can manage the various pages that are part of the site. So I have, all the different pages that are part of my site represented here, and I can go in and I can maintain the different settings that are related to a page, maintain the permissions as well. If I go back into the admin panel, so you can basically create as many users as you want that are part of this particular site. You can set up the profiles, which are basically the different profile fields that you want to capture or allow users to capture related to a user account. And you can add additional profile fields as well. You have role management. You have a file manager where you can keep track of files, create as many different folders as you want as well, and also maintain the permissions for those. You've got a recycle bin for things that get deleted from the site and you perhaps would like to bring back or permanently delete. You've got an event log where you can see all of the different activities that have happened to a particular site. So everything, there's an audit trail for everything within Oqtane, and it's tracked, and you can view it through the event log. You've got your tenant management, where you can manage the various databases that are part of your installation. By default, there's only a single tenant, but you can create as many tenants as you want in the multi-tenant capability. You've got your list of modules, where your different modules are located. You can choose to install your modules here as well. So you can actually download modules from NuGet directly and install them seamlessly, or you can upload your module packages as well. Similarly, you can do the same thing with themes. Your scheduled jobs are basically where your scheduled jobs are set up to run. By default, there's a notification job which sends out email. So it's got a full notification system that's built into Oqtane as well. So this is for system notifications as well as user-to-user notifications. You've got SQL management, where you can query your database directly and interact with your various databases through the application itself. System info basically tells you what version of Oqtane you're running, what hosting model you're using, what version of the CLR, and various aspects. You can also access the Oqtane API. So you've got, of course, the full swagger, like I mentioned earlier, for all of the different APIs that are available as part of Oqtane. So this provides a great sort of overview of the different APIs that are available as part of Oqtane already. And there's a system update capability as well. So you can basically, this automates the update of the Oqtane framework by downloading the latest version. It allows you to download the latest version from NuGet and refresh your system very simply. So those are some of the different administrative capabilities that are available as part of the Oqtane framework today. If you want to get started with developing for Oqtane, the simplest way to do that is to use, basically scaffold a module. And the way that you would do that is you would go into your control panel, go into module management. There is a special category of module called developer modules. So I choose that. I choose my module creator, and it enables developers to create modules by automating basically the creation or scaffolding a lot of the code that you would need to create a functional module. I'm going to add that to the page. It allows me to provide some basic information that for customizing the module. So I can basically, specify the name of my organization or company. I provide a module name and a description. I have the ability to choose from a few different template types. So internal module would be created within the Oqtane solution itself. This is only really useful if you're, just experimenting with Oqtane and want a simple way of getting started. Most often you'd use the external template. The external template basically templates out an entire set of code for you for an external module. You can target different versions of the framework. So any version as well, or if you're using, the latest version from GitHub, you can target that as well. And so basically, this will create a module for you. I've already created a module using this mechanism, and that's how I created the .NET Foundation projects module. So you can see here that it scaffolded out a lot of code for me. It created a solution file for me. It created a client project, a server project, a shared project, and even a packaging project for me. The client project has all my Razor components and my services. It scaffolded most of this for me, and then I just had to adapt it to my needs. This particular dnf.projects project is actually available on GitHub. So if we go to GitHub in the Oqtane organization, we can see the dnf.projects project here. And this contains all of the code for the DNF projects module. And if we want to look at the runtime characteristics of that, we can see it here. So you can go to this particular site, and it basically shows you information related to the different projects that are part of the .NET Foundation. Right now, by default, it's pulling pull requests, the total number of pull requests between this date range. And we can see that, this particular project, Azure SDK for .NET, had 659 pull requests in the last month. We can go into view, and it actually shows a line graph of various types of activity, both watchers, stars, forks, contributors. All of this information came from the GitHub API. And it is basically, if we go back to the code, we can see that there's in the server project, there's a scheduled job which runs. A scheduled job is set up here to call out, and it's actually using REST#, and it using the REST client, REST client, to call out to GitHub. It authenticates, and then it, of course, calls various APIs to retrieve information, which it then stores in the database. So this job is part of this module, which is deployed to Oqtane. And then in the Oqtane environment itself, if I go into my scheduled jobs, we can see that this GitHub activity job is scheduled to run every day, and it runs my project job. But anyways, so I think I'm up to the end of my time. So I hope I've provided you enough of an overview of both Blazor and Oqtane to excite you about some of these new technologies, and I would encourage you to get out there and download them, give them a try, and I think you'll find that they're quite productive and useful. Thank you very much. I appreciate the opportunity of talking to you today and sharing this with you. And I hope you enjoy Programmers Week.
Shaun, there are a couple of questions.
Okay.
The first, do you want me to read them?
No, I've got it open here. So what is Swagger? So Swagger is a it's become quite a popular way to expose an API, and I did show you that in my presentation, where you can basically load up a Swagger view of your backend API, which basically it shows you all of your API endpoints for your application. I can actually show you that again here. So if I go into my admin dashboard, system info, this is my Swagger UI. So Swagger, it basically builds a user interface for you dynamically based on your web APIs, and you can click on any of these and it tells you information about them, and you can even if you're authenticated, you can try it out by entering various values to pass into the APIs. So it gives you a lot of useful information. Next question, do I have a demo that demonstrates the multi-front end with Oqtane? So in fact, I mean, the default implementation of Oqtane uses multiple front ends already. So when I'm running the application, sorry, close that. Sorry, wrong one. So if I go back to this application here, and I go to my home page, I mean, this is a module. This is an HTML text module. This here is a module creator module. So these modules may be part of the Oqtane framework, but so let's if I go in and let's remove this module from the page, and I'm going to add an additional module. I'm going to choose from common. The .NET, the project module that I just showed you, I can add that to a page as well. That was deployed as a completely separate assembly. So, but it looks like it's just part of the overall solution, and I can go in and I can interact with it. But all of the functionality from this particular module instance that's on the page is coming from a completely separate independent assembly, independent from Oqtane. So that's how you would build sort of using that sort of micro front end capability. Next question is, what's the difference between .NET Core and .NET Framework? So I think that there's probably that's quite a large question to cover, and probably it's best to look that up on in the Microsoft site. .NET Core, I mean, started. I think the first version of .NET Core came about in 2015, so it's probably 5 or 6 years old at this point in time. .NET Framework's been around for much longer. So .NET Framework started back in 2000, so it's almost 20 years old. At this point, Microsoft has announced that they're no longer going to be doing any enhancements to the .NET Framework. It's basically going to continue to be supported going forward for quite a period of time, I think at least for another 10 years, but there's no new development work that's happening in the .NET Framework. All of the focus has shifted over to .NET Core, and .NET Core is obviously becoming part of .NET 5. And so, I mean, as far as the recommendation from Microsoft for building modern applications on the Microsoft platform, you should be building new applications on .NET Core, because .NET Framework is going to be considered a legacy technology very soon. Even if it continues to be supported, it of course will be, it's not where the main investment is going from Microsoft. So I hope I answered those questions. All right. I think that wraps up my presentation. Thank you very much for the questions.